All right. Thank you for watching yet another video. Yeah, I'm just getting right into this. I'm tired and I want to go home. So this is a short video. I don't know if it's going to be short. Actually, it might be long. This is a video on quadratics. And specifically, this is an introductory video to the quadratic formula, which you see here, where x equals negative b plus or minus the square root of b squared minus 4ac all over or divided by 2 times a. So where do the a, b, and c come from? Everything else is the same. The fraction bar is always there. You got negative there. You got plus minus square root, squared, minus 4, 2, all that stuff's there. But you need to substitute in a, b, and c values in. So ax squared plus bx plus c is standard form of a quadratic. So that's where a, b, and c come from. Now, if there is not a visible number in front of x squared, then a is equal to 1, or negative 1 if it's negative x squared. Okay, so 1 is kind of invisible. It's insinuated. If there's not a number there, it's 1 because 1 times x squared is x squared, and we're just going to write x squared. Anyways, moving on. So let's just get straight into the examples of how to use the quadratic formula to solve. So the reason why we're solving for x is because, again, when you're solving for the solutions of a quadratic, you're setting that quadratic equation equal to 0, and you're solving for the x-intercepts. We're finding the x values that give an output of 0. We're finding the x values that if I were to plug the x value in and do a bunch of math and compute it, I would get 0, right? So we're finding the x-intercepts. What do we plug in to get 0? All right, so let's go through here. So we have our b value. All right, really important that negative goes with it. We got our a value. And we have our c value. And we are going to plug all of those in. So really important, that negative is always there. So I have a negative, and then I'm going to substitute in for b a negative 4. And then we got plus or minus the square root of what? So I have b squared, but that's going to be, in this case, negative 4 squared. Really important when you substitute in a negative number, highly important that you put parentheses around it. All right, because this is a negative times a negative, and now this is negative 4 squared, not negative 4 squared. This is negative 4 squared, right? This is negative 4 times negative 4. So really important that you use parentheses. And then we got minus 4. That's always there. And then I'm going to set up some more parentheses, substituting in numbers. So I'm going to substitute in what is my a value. My a value is 15. My c value is negative 3. All of that is going to be over 2 times 15. All right, so really important again, we have our b value right there. We have our a value where a is supposed to go. We're substituting a in. And then we have our c value where c is supposed to be substituted in. All right, so now we're going to simplify one step at a time. Simplify one step at a time. Maybe not one step, couple steps, but small steps, small incremental steps. So negative times a negative is a positive. So I get positive 4 plus or minus the square root. I'm going to do negative 4 times negative 4 is positive 16. I'm then going to simplify this stuff here. Negative 4 times 15 is negative 60. And negative 60 times negative 3 is positive 180. And then that's still all over what we now have is 30. So I simplified this, I simplified that, I simplified that, and I simplified that. So I didn't try and simplify everything all at once. I simplified little bits at a time. The next thing I'm going to simplify is this inside part. So I'm going to have 4 plus or minus the square root of 196 all over 30. All right. I should probably, just for the sake of this, separate out where the steps are. All right, so we don't get those confused. All right, what do we got next? Well, can you find the square root of 96? And if you can't, you need to simplify it. Now, luckily, the square root of 96, 196 is not 96, 196. 196 is a perfect square. The square root of 196 is 14. All right, so that works out really nicely that I can now change this to be 4 plus or minus, what did I say? 14. 14, yes, 14. Jeez. Like I said, tired, ready to be done making videos. I'm gonna zoom out. So we are here. On to the next line. Now, and by the way, I haven't been writing it, but these are all x equals, x equals, x equals, x equals. We're finally to the point where we're going to separate this out into 2 separate things. All right. So I'm going to separate this out into 4 plus 14 divided by 30. And I'm going to separate this out into 4 minus 14 divided by 30. All right. The plus or minus is 2 different things. What do we get here? So 4 plus 14 is 18. So I'm kind of running out of room on this problem. We're going to get 18 thirtieths, and then 18 thirtieths is going to simplify to be, what can I divide out of that? I can divide a 6 out of it. 6 goes into 18 and 30. So 3/5. So that goes to there, that goes to there. Terrible error. Okay. So how about over here? 4 minus 14 is going to be negative 10 over 30. And I can obviously factor out a 10 out of that. So I'll divide 10 out and I get negative 1/3. So that goes to that. See if I can make these arrows a little bit better this time. That goes to that. All right, so those would be my 2 answers. So I get x equals 3/5, comma, negative 1/3. All right, so pretty lengthy problem. You can do it in fewer steps, but I choose to not, 1 step at a time, slowly break it down. That way you do not mess up, all right? Even the best mathematicians, you're tired, you do a lot of problems, you mess up in a little tiny step, and then the whole problem ends up wrong, all right? So when there's lots of steps to be done, make sure to just do them all and double check every time you do one. Double check you did it right before you go on to the next step, or else you're gonna mess up. Okay, I like it. Worked out. By the way, these are rational numbers. These are rational numbers. What is a rational number? A rational number is a number that can be written as a ratio of 2 integers. So 3 to 5, 1 to 3. Basically, a rational number is a number that can be written as a fraction. All right, so a rational number is a number that can be represented or written as a fraction. So these are rational, because that's going to pop up. These are rational numbers. All right, these rational numbers. That's going to pop up later. Now I'm going to try and break this down into, or at least I'm going to write smaller, I guess is what I'm going to do. So we have A, B, C. So we're going to get negative negative 21 plus or minus the square root of what? We're going to have negative 21 squared minus 4 times A times C. All right. And that's all over 2 times A. So what are we going to get? Negative, negative is a positive. So we get positive 21 plus or minus the square root of 21 squared. I want to say that is 444. We don't know. 441. So negative 21 squared is 441. Then we're going to multiply all these out. So we're going to get minus, because there's only one negative. So negative 4 times 4 is 16, and 16 times 10 is going to be minus 160. Okay, so this is all going to be over 8, because that's 2 times 4. So again, let's separate these steps out. All right, let's separate this one out from the next one. Okay, so let's simplify again. You're going to simplify the inside. So I'm going to get 21 plus or minus the square root of what is 441 minus 160. It's 281. And I'm hoping that is a perfect square. Square root of 281 is not, it's got to be like 17 or 16. Or it doesn't work, which would be fun. Yeah, doesn't work. Oh, son of a gun. You know what? This right here is a prime example. Thank you for watching. Prime example of where did I go wrong? Yeah, that dramatic pause right there was hopefully because it clicked in your head and you're looking for where I went wrong. And I will tell you where I went wrong. And I will do this whole problem over again in this video. And my students know I mess up sometimes. It is okay. People make mistakes. Is this bloody problem set equal to 0? No, it's not. All right. You cannot start solving a problem until it is set equal to 0. You cannot use the quadratic formula unless it is set equal to 0. Son of a gun. Okay, so to solve this mishap, I am going to add 5x squared to both sides and start this whole thing over again, because why not? Because why not? I'm going to do it in a different color though, so nobody gets confused. So let's cross out all of this fun stuff and let's go with blue. All right, son of a gun. So I'm going to get 4x squared plus 5x squared is going to be 9x squared minus 21x plus 10. And it's now set equal to 0. So I'm going to zoom in on this because I'm going to write a little bit smaller. Just for the sake of the room that I now do not have to solve this. So we have A, B, and C. So we're going to get still negative 21. So negative 21 plus or minus the square root of negative 21 squared minus 4 times 9 times 10. And then we are going to get 2 times 9. Okay, so that separates out right there. So that's one step. And then we're going to get positive 21 again, plus or minus the square root. Again, we're going to get 441. That hasn't changed. But here we're going to get a different number because it's no longer 4 times 4. Now we got 4 times 9. Negative 4 times 9 is negative 36. And negative 36 times 10 is negative 360. All right, it's making a whole lot more sense now. We're going to get 18 down here. Again, separating this out. So our next line is going to work out because now instead of 281, we're just going to get 81. So we get 21 plus or minus the square root of 81 over 18. All right. And hopefully we all know the square root of 81. All right. We're going to get 9. So we get 21 plus or minus 9 over 18. So at this point, I'm going to separate this out. And I am going to get 21 plus 9, which is 30 over 18. And over here, 21 minus 9. So 21 minus 9 is 12. I want to say 12. 21 minus 9, 12. Yeah, 12/18. All right. And then for the sake of time, I'm just going to separate these out. I'm going to simplify them. So we get 30. What, 6 goes into that again? So that is 5/3. And this one is, you can divide 6 out of that also. So this one is 2/3. All right, again, these are fractions. They're rational numbers. These are rational. They can be written as a fraction. Thank you for bearing with me. Lord, I can't believe I messed up that bad. I almost did an entire problem wrong. All right. So it is okay if you make errors. Just learn from those errors, figure out where you messed up, ask your teacher, and they will guide you towards a learning experience. Oh, okay. Now we have some different stuff happening. So I'm going to tell you right now, this problem's going to end up a little bit different. Switch back to this color, zoom out again. All right, so A, B, C. So we got negative 13 plus or minus the square root of negative 13 squared minus 4 times A times C all over 2 times A. All right, so we're going to get positive 13 plus or minus the square root. 13 times negative 13 is positive 169 minus 16. 4 times 4 is 16, and 16 times 6, 4 to 96, 96. 4 times 4 is 16. 16 times 3 is 48. I think, yes, it is 96. All right, rocking with 96. And then we're going to get 2 times 4 on the bottom, which is 8. All right, so we got 96. Now we're going to have 13 plus or minus. We're going to simplify the inside of this square root. I'm not going to try and do that in my head. I'll mess up probably. So minus 169. We get negative 73, not negative, positive 73 over 8. So running into an issue here. Before, when we got to here, oh, what's the square root of 81? It's 9. Right? Square root of 81 is 9. Is 73 a perfect square? No, it's not. I even think 73 is a prime number. I don't think anything goes into 73. I don't think so. I'm pretty sure it's a prime number. So that's an issue. That means I cannot simplify it. And I'm going to double check on that. So I start off by, it has to be an odd number. Obviously, even number is not going to go into 73. Well, it might. I don't want to say it's not, but it might not. So what are some perfect squares? I got 4, 9, 16, definitely not 25. And it's definitely not 36 because that would be 72, not 49. So let's try some of these. Let's do 73 divided by 4. Yep, doesn't work. 73 divided by 25 would be the only other one. That doesn't work. Oh, wait, I guess 73 divided by 9, maybe, divided by 9. Yeah, that doesn't work, 8.11. So it's not a perfect square, and you can't simplify it either. You can't simplify that radical. So you leave it like it is. That's the answer, actually. X equals, X equals, X equals that. The only, that's how I would answer it. I would leave it as this. This is an irrational number. You can't write it as a fraction, right? The radical, it's irrational. You can't rationalize it. That's done. It's over. The only thing you could do is if your teacher asks you to, which I'm not asking of my students, is you can separate this out to be X equals 13 plus the square root of 73 over 8, comma, 13 minus the square root of 73 over 8, and separate them out. But it's totally fine if you do plus or minus. I know that means two answers. Hopefully you know that means two answers because you got the plus or negative version of that. All right, let's go to one more example of quadratics, and then we're going to talk about the discriminant. So almost done. This video is almost over. Okay, so here's one where the A value is equal to 1, and then we got our B value and our C value. And, is A equal to 1? Oh, yeah, it still is, but I don't actually have my B value yet because I'm not going to make this mistake twice. I need to subtract this 4x across first. All right, need to do that first before I do anything. So actually, I got x squared minus 9x plus 17 equals 0. Okay, now I have my A value and my B value and my C value. All right, let's rock and roll with that. So we have negative 9 plus or minus the square root. So far, I don't know how this has happened, but every single B value of the examples I chose happen to be negative. That's not always going to happen. Sometimes you'll plug in a positive there, which is totally fine. So B, so we get negative 9 squared minus 4 times the A value, which is 1 in this case, times the C value, which is 17, all over 2 times the A value again. All right, we're gonna get positive 9. Negative times a negative is a positive. Negative 9 times negative 9 is 81. Minus 4 times 1 is 4. 4 times 17, 34, 68. 68. All over 2. 2 times 1 is 2. Okay, so 4 times, double check in my head. Yeah, sounds right. What's 81 minus 68? 13? Is it 13? I feel like it's 13. Yeah, it's 13. So we're going to get 9 plus or minus the square root of 13 over 2. Again, 13 is a prime number. You can't simplify 13. It's prime. It also doesn't have square root. Nothing goes into it. It's prime. So x equals that is the answer. All right. So this is an irrational, just like the last one, irrational number. All right. You cannot write it as a fraction. You have to keep the radical sign there. All right. I get that that's a fraction, but it's not just a fraction. It still has the radical. It still has the square root in it. It's not just a fraction. Okay, so very last thing, the discriminant. So this will be important. Discriminant tells you a lot about the types of solutions that you'll be getting. And for my students tomorrow, they're going to be getting, so far we've gotten real. We've gotten 2 real, right? So far, this answer We got two real rational. So this is two real rational numbers or solutions. All right. Here, this has two real. I don't know why I'm putting a comma after two. I really don't know why I'm putting a comma after two. You don't need a comma after two. Actually, it shouldn't be there. It's just incorrect. Two real irrational numbers. Okay. So in another video, I'll have another video posted about imaginary or complex solutions, non-real. Imaginary, complex just doesn't float the boat, doesn't work out. So what I'm going to do here, I'm going to find a highlighter. This right here, the inside of the square root is the discriminant. So the inside of the square root of a quadratic is the discriminant. So b squared minus 4ac. If, let's say if, run out, I'm grabbing some new colors. That's the same color as if b squared minus 4ac is equal to 0, then you get one real solution. All right. And basically what that means is both of the roots, that means both roots are the same rational number. This means both roots are the same, and that's equal, means equal, right? Same in math means equal, or the both roots are the same real rational numbers. All right, that basically means, like, if an example of that would be x, like if you're to factor something out and you got x minus 2 times x minus 2 when you factored it, well, both of these roots are 2. So you have one solution, which is 2, but technically it's still two different roots. Is how it works out. So you get one real solution, which means that both of the roots are the same real rational number, which means you get one solution, because 2 is equal to 2, and you're not going to write 2 twice. You're going to write it once. What else do we got? So here we have it's equal to 0. What happens if it's greater than 0? What happens if it's a positive number, right? What if you do all of this inside and you have this square root of a positive number? So what happens if b squared minus 4ac is greater than 0? This means you're going to get it could be two real rational or irrational, but you're going to get two real solutions. So you're going to get two real solutions. Also, I want to point out, what does this mean on a graph? So that means on a graph for like this one, it comes up and touches. All right. It touches, does not cross. It touches at one x-intercept. If the discriminant is bigger than 0, that means that it's going to cross and have two solutions, right? It's got two solutions. All right. And how can you explain this one? Well, you can explain this one as the two roots, the two solutions are different rational or irrational. If you can't find the square root, like if it's a square root of 13, you're going to get an irrational number. Rational or irrational real numbers. So they're real. You can see them. You can see that that crosses the x-intercept. Those are real numbers. But they are different, right? You're going to have two different answers. You're not going to get 2 and 2. You're going to get, I don't know, 3 and 4. Or like these other problems, you're going to get 9 plus the square root of 13 and 9 minus the square root of 13. Two different numbers. Now, what is going to be talked about in a later video is what happens if there's a negative on the inside of this. So we're actually going to leave a big question mark here for when it is less than 0, because that will be discussed in another video. I lied. My students have part of their assignment. They need to know this. If the discriminant is negative, if there is a negative number inside of the square root, if the discriminant is less than 0, you are going to get imaginary solutions. All right? They're not real. They're imaginary. Why do we have them? Because there's some math that actually is beneficial to have them. Probably not, well, I don't want to say not that any of you would do. Maybe you will do it. Maybe you will use them in math. I don't want to hold you back. Imaginary solutions, what do we have? Imaginary solutions are going to have an I, and we will talk about that in a later video. For now, all my students need to know, and if you're watching this, is if the discriminant is a negative number, if this is a negative number, then you are going to have imaginary solutions, and you're actually going to have 2 of them. And what that looks like is if the graph doesn't cross, if the parabola of the quadratic does not cross at all, doesn't cross it, you can't see the solutions. It means they're imaginary. It means that you're going to have a negative inside the discriminant, and we'll talk about how to solve that later. Just know that if you see this, imaginary solutions. If you see that it's a negative, if you do the math here and you get a negative, 2 imaginary solutions. All right, I'm tapping out. This video was too long, and I need to go home and download it on YouTube still. So thank you for watching. I do hope this was helpful. Yeah, stay tuned for more.